Hello everyone. We are going to start our lecture on confidence interval, which is the first topic of inferential statistics. We are going to first explain what confidence interval is, the concepts behind it, and then we are going to go through the process of finding a confidence interval. Now, these are some of the topics that we will be covering in this lecture. First, we'll talk about what confidence interval is for one population mean. Then we'll go into the terminology of point estimate, because a confidence interval will need to be developed around a certain value, which is called the point estimate. And then there are two ways of finding confidence intervals. One process is when the population standard deviation is known, and the other one is when the population standard deviation is unknown. So we are going to go through these topics one by one, starting with explaining what confidence interval is, the meaning, and what it implies as far as statistics is concerned. Now, since confidence interval is a topic of inferential studies, let's talk about what inferential studies is about. Now, if you recall, we were told in the beginning of Statistics 1 that statistics can be divided into two types. One is called descriptive statistics, and the other one is called inferential statistics, correct? So there were two types of statistics. Now, what is descriptive statistics? Descriptive statistics comprises of these three elements. The first is to collect the data that we are going to study for statistics, collect the data, then we would have to organize the data, and then finally, after we organize our data, we take measurements on the data. All right? And the measurements that we take give us the mean, the median, the mode, the standard deviation, variances, and so on. All right? The standard deviation, the variance, etc. So all these three steps comprise what's called descriptive statistics. Now, we also said that our statistical study applies to a certain population. All right. However, the population can be an enormous size. It can be in millions, and it's not possible to work with an entire population because it can be in millions. It's going to be time consuming. It's not going to be cost effective. Therefore, what we do is we get a subset from our population and create what is called a sample. So instead of working with an entire population, we obtain a subset of the population, which is called a sample, and we perform our descriptive study on our sample data. All right, so we collect the data from our sample. Once we collect the data, we organize and take measurements, but all of that is done on the sample instead of the entire population. Now, once we are completed with all our descriptive functions, we use the findings from our sample and try to draw conclusions on the population. All right. So what we do is, again, we take our findings obtained from our sample study and we try to estimate what the population measures are going to be. So inferential study involves drawing conclusions on the population from our sample study, from the sample study that we did when we were performing our descriptive statistics from the sample. All right, so drawing inferences, drawing conclusions, making estimates all fall under inferential study, forecasting. All right, so forecasting, but all the inferential study is done on the population. So descriptive study is done on the sample, whereas inferential study is performed on the population using our sample study. So descriptive statistics and inferential statistics go hand in hand. Now, how does confidence intervals come into play here? When we perform our sample study and find a mean of the sample, it is not appropriate for us to say, hey, the sample mean was a particular value. Therefore, the population mean is going to be exactly the same value as whatever my sample mean is. Right? That is not appropriate. Why? Because the sample was worked from a small subset of the population. Right? The majority of the population was not included in our sampling study. Therefore, there's bound to be sampling error. That means differences in measurements because we are working with a small subset of the population instead of the entire population. So sampling error is going to come into play. Therefore, there is a strong probability that there's going to be some difference between the sample measures and the population measures. All right. So therefore, instead of giving a specific value for the population mean, we give a range of values. All right. We give a range of values, also called an interval, within which the population mean might fall, within which the population measures might be or might fall. All right, so this was just to relate confidence intervals with inferential studies. Okay, we will now go into explaining in more detail the concept behind confidence intervals. Try to understand the concept of confidence intervals with a common example from our lives. Now, in this picture, we see a jar filled with candy corn. Let's say we are invited to play a game of guessing the number of candy in the jar, and we are told that if we can guess the exact number of candies in this jar precisely, then we'll win a prize. How much confidence would you have to guess the exact number? I would say I would have zero confidence or close to zero confidence in being able to guess the exact number of candies because it's not possible to do so without counting. Now, if instead we were told that, well, you can be off from the exact number by plus minus 25, you'll still win a prize. So let's say the number of candies in this jar is 500. And we are given an allowance to make an error within plus minus 25 of the exact number. Now, what does that mean? So we have over here in the center our exact number of candy corn, which we wouldn't know, the person who's playing wouldn't know, but there are 500 candy corns in this jar, and we are told that since it's not possible to guess the exact number, you can make an error within plus minus 25 of the exact number and still win a prize. So what does plus minus 25 mean? That means you can guess a number anywhere between 475 and 525 and still be considered correct, still be considered close enough to win the prize. So what they have done here is given us a margin to make an error and still be considered close enough to win the prize. So this interval of values within which we can guess a number and still be considered correct is called the confidence interval. And what happens is that when we are given a margin, our confidence interval rises up. It goes up a little bit maybe. Okay, so our confidence level goes up to play the game. Let's say they increase that margin. So we still have the 500 as the exact value. And they tell us that, hey, instead of plus minus 25, if you are within plus minus 50, we'll still give you the prize. So what happens now is they have increased the margin. They've given us a wider margin within which we can guess a value and still be considered correct. So plus minus 50 means our interval endpoints are 450, the lower end, and the upper end is 50. 500 plus 50 is 550. So if we can guess a value within this interval, we will still be considered close to the actual value and win a prize, right? So that's what confidence interval is about when we go on to statistics as well. Now, one thing I want to mention here is what happens as we increase the margin of error. As we increase the margin of error, our confidence level goes up. So when we were told our margin of error is 0, and that means we have to guess the exact number of candy, our confidence level was practically 0, right? When they gave us a margin of plus minus 25, our confidence level increased, right? It went up a little bit. When the confidence interval was made wider, when we were given a wider margin of error, then our confidence level went up even further than it was when the margin was plus minus 25. Correct? So as we keep increasing the confidence interval, the margin of error also increases. So increase your confidence interval, your margin of error increases as well. All right? But what happens to the precision? The precision, however, keeps going down. As you increase your confidence interval, you are given a wider bandwidth to make error, to be off from the actual value. So that means your precision falls. All right, so let me just write that down because we will need to apply that information in answering questions in statistics when it comes to confidence intervals in statistics. So we will have confidence, let me just pull up my pen here with a different color maybe. So we have confidence intervals, margin of error. The margin of error is denoted by the letter E, and then there's precision. So this is error, and this P stands for precision. Precision means accuracy. So when confidence interval is increased, the margin of error increases, but the precision falls. When confidence interval is decreased, the margin of error is also decreased, but the precision goes up. So narrower the interval, narrower is the margin of error, smaller is the margin of error, but you have to be more precise in being close to the actual value. So your precision in that case increases. You have to be more precise. You have to guess a number closer to the actual value.